Good day, everybody. Welcome. My name is Wout, and today and I'm from Fairbanks International Group. Within that group, I am active as the CTO of 42On, one of the companies within the group. The other part is Fairbanks. Some of you may know me as a Ceph guy, or because 42On is a Ceph company, but as a group, we manage private clouds for organizations. Today, I want to share with you a little bit about what we do, why we do that, and why we choose Talos to do that. And I do that with the subject of OpenStack. By the way, I'm aware that I'm standing between you and the drinks after, so I'll try to keep that in mind. So we are Fairbanks and 42On, the Fairbanks International Group. We are a European-based, a Dutch company, and we are committed to providing organizations with sovereign private clouds. We do this with a focus on Kubernetes for container-based application orchestration, as if there's anything else really. We do that with Ceph for storage and OpenStack for IaaS type services. We support organizations using these technologies, and we do that with a variety of services. So we do that with some consultancy. We do that with emergency assistance, which is 24/7 based, contract-based support. We do training, and the main focus of this talk, we do that with managed services. We do that worldwide, so we are European-based, but we do that for many different organizations in a lot of different countries. Last year, so March at KubeCon, I've seen some of you there. We introduced with Sidera Labs joint support for Ceph on Talos, and we've now added OpenStack to that stack. So a few things first. So we understand that the future is cloud native, right? So and I think everybody here understands that. So we are not doubting that, and we are trying to figure out what does that mean for OpenStack in a cloud native future. So we, all of us, the market, will need to continue IaaS services for a while. Then OpenStack is the de facto standard IaaS infrastructure as a service type solution that is open source. And we think that Sidera Labs' suite of running Kubernetes is just the very best way of doing that. So the challenge for us is how do we combine all of that while still trying to reduce complexity. Now to highlight or to zoom in a little bit on the first item there, with we the market, I mean we the market, we didn't make that up. We partner with Gartner, and they predict that in 2028, 75% of applications will still run not containerized. So it will still be either bare metal or virtualized workload. At the same time, 95% of organizations are using containerization at the same time. So these worlds will have to coexist. There's absolutely no doubt there. Another thing we kind of thought, and again, not just us as a company, but what we thought in general is that the IaaS game or the IaaS marketplace and technology was kind of set. We saw some people moving to public cloud. We saw some people moving back. There might have been an exchange or two between two companies or two different technologies, but that's about it. There were no real big movements there. That all changed last year. when VMware announced their big change, or when Broadcom actually announced their big change in policy. I don't know, is there anybody here running VMware? Anybody impacted by what I'm implying here? So and without that, it would just have been said. Nobody would have thought about anything, and you guys wouldn't even be here probably in this talk. So thanks. But that's a real challenge. It's a real challenge to now, when everybody was kind of winding down in that and set in their ways, there's disruption in the market. It's a lot of fun, a lot of cool conversations that we're having in the last couple of months. So there's a need for hybrid infrastructures. That's basically the conclusion here. There's a need for hybrid infrastructures, and then it becomes a question of how do you layer those, how do you approach that. And these, by the way, these are just quotes from Gartner again. I actually, oh, there it is, yeah. So one of the things that is very important in this advice from Gartner is that they say, you wanna, whatever you're considering, make sure that you don't try to improve everything, but sort of horizontally move, because the business risks of doing like a full improvement and a change of your infrastructure and change of your architecture and a change of your culture is going to be very difficult, and you might not make it in time. So how are you going to do that? And how are you going to do that with avoiding new vendor lock-in? So on the one hand, they're advising just look around. They're not even advising go away from VMware, but just consider things. And the other thing is invest into new things and don't do too new stuff. And I think it's quite difficult to sort of navigate your way around there. So I just want to highlight this one because it's sort of I don't think it's an elephant in the room, but it is a question that everybody has, is how does KubeVirt fit into this? How does KubeVirt fit into virtualized workloads and infrastructure as a service within a Kubernetes ecosystem? And we see KubeVirt as a great technology and as a very promising technology, but it's just not there at the level what true IaaS solutions are providing to these teams yet. And the quote there is directly from the website. It's like the second line on the website where they say this is for developers wanting to have virtual machines with their Kubernetes based applications. So we kind of see it as KubeVirt is very cool and very nice for some virtual machines in a Kubernetes cluster, whereas OpenStack is a full IaaS solution that will give your teams infrastructure access and infrastructure control. So OpenStack on Talos. These 4 items are what we carry as a company. This is what we want to do as a company. So we aim to reduce complexity for our customers. We aim to increase their control, increase convenience, and in the meantime, we are also dedicated to increasing positive impact, so decreasing our footprint, all of that. With this solution, we're mainly focusing on reducing complexity. So we have a stack, an OpenStack stack. We're introducing something as simple as Kubernetes to reduce complexity. So why are we doing that? And why are we choosing it to do it that way? So when you look at it and when you have worked with these 2 technologies, where I'm mentioning Ceph a bunch of times, but this talk is not about Ceph, but OpenStack and Ceph are near cloud native or cloud native. Mostly some components are very cloud native and some components are very much not like cloud native, are very stateful and very static. So some parts are easy, some parts are harder. They are service oriented and already containerized. So most of the Ceph environments, for instance, that we see in the wild now that have been deployed in the last, let's say, 3 to 4 years, are already containerized versions. So we're moving towards cloud native, and we see that that actually is an evolution of OpenStack, for instance. So I was talking earlier. You see that OpenStack used to be like a very difficult and very cumbersome and big and monolithic almost in some ways, but many of the functions have been split out into different services. So for those of you who don't really know OpenStack, I have the pleasure of trying to explain OpenStack in 2 slides or less. So I'm trying to do that now, and I'm trying to explain the architecture a little bit. So it's similar to Kubernetes in the way that it has a control plane and it has a sort of worker plane called, and we call those the compute nodes. The control plane is databases, message queuing, and a lot of small components, smaller services that actually do the OpenStack functions. So that's the control plane, and the control plane has complexity, but that is complexity that you want, because if you want to be able to launch virtual machines, you'll want a service that can launch virtual machines, and you want to be able to call that service, and you want that service to have network functions, and so that is sort of the inherent complexity of OpenStack. That is just how complex the product is. We have compute nodes. That is basically the worker node, but that's where the virtual machines live. So while they are sort of simpler in design and simpler in terms of complexity, they are doing the heavy lifting and they are doing most of the work, and they are probably sort of most important. Everything that you see here is already, there are containers already for that. It's been available for a long time, tested out and stable. And then we have the secondary component. So we have things like pacemaker, coresync, and HA proxy. And a lot of those terms are no longer really applicable right now, but for a traditional setup, it is. We have secret management to worry about. And of course, we have OpenStack upgrades to worry about. This is all accidental complexity. Nobody benefits from that complexity. It's just there to make sure that the inherent complexity gets delivered to your doorstep. That's the only thing that it really does. Also, OpenStack Helm is already there. So there is a nice system for you, and it's just one of them. There are a few ways to do this. But OpenStack Helm provides you with just about everything you could want to deliver OpenStack on Kubernetes in just about every configuration way that you would like. Works on Kubernetes on top of Ubuntu, works on Red Hat's Kubernetes just fine. So a simplified version of what that looks like, and this is really drawn to just sort of facilitate my talk more than it is a direct design. But you can see that our OpenStack environments are basically split into a couple of logical units. So on the left you have the sort of third-party type services, databases, Memcache, and Ceph that are just there as supporting parts of running OpenStack. Then we have the controller hosts where actually the OpenStack services are running. Then we have the network host, which facilitates all the network connectivity and routing and load balancing and all of that. And then we have the big one, the compute. Now for our purposes here, most everything that's blue kind of works anyway. When you run it on a Kubernetes environment and when you run it on Talos, that kind of just magically works. Why? Because it's a near cloud native application on that end, near cloud native. This is all where it starts to be a little bit more challenging. So how, if I look at this as a traditional setup, how would you do that? Well, you can use the Red Hat director. So that's a thing that I always found interesting about OpenStack. It was, until recently, it was the only tool that I really knew that had deployment tools and systems designed just to do OpenStack. So a lot of you probably know something like Red Hat Satellite or Red Hat Director is another tool. It is only there to deploy and manage OpenStack. Why? Because at the time that OpenStack was started, you needed something to do that because you cannot do all of those services by hand. And many organizations started developing that back then. The director evolved, fortunately, to using containers also, but it's using just local podman containers, just locally managed, no orchestration from Kubernetes or anything like it yet. And they are kind of in the middle of shifting that to OpenShift. So it's OpenStack on OpenShift. Then we have the Juju stack from Canonical. And anybody here work with Lexi containers? It's like 5, 6-ish. Lexi containers are interesting and fun, but they look an awful lot like virtual machines when you manage them. Basically, when you log into them, you cannot really distinguish it from a virtual machine. And also, that is the way they are managed in a Juju environment. So that means that if I have 15 containers, I have 15 operating systems to update, manage, all of that. Then we have Cola Ansible and OpenStack Ansible. The top two we use in the organization. Historically, the bottom two we don't, but they exist, and they are used in the marketplace. What our consideration here is that these all deliver pretty much very mutable infrastructures, usually. So that to us looks a little bit like this, that stack. So I have hardware in the bottom, then I have a general purpose operating system, and I have some services on top of that, managed by systemd. Then I have an Alexi container in the case of Ubuntu, which contains another operating system, which contains more services, which then at some point provide us with the OpenStack APIs. And then we have virtual machines, and in the virtual machines we have another stack of operating systems with another stack of services, and so on and so on. This is kind of a high tower in some cases, and what we see or know from doing managed services at different companies is that most of our effort goes into the layers down there. That's just where the work is, which is all work that touches none of the customer value, really. It doesn't, the best thing you can do is not fail, basically. That's the highest praise for operators, right? You didn't fail. So we are aiming to, we see this as complex, by the way. And the reason we see this as complex is because it has a lot of cogs and a lot of moving parts that you need to manage. And that is all accidental complexity. So what we really want is to get the bottom closer to the top. We want to cut out parts. That's really what we want to do. And with cutting out parts, we mean cutting out effort. Not worry about those parts, or at least not worry about them all the time. Just have moments in time when you can worry about them. So we want to move to an immutable stack where we can, which is difficult when you're talking about stateful stuff like Ceph and stateful stuff like virtual machines. So we're aiming to do this, and this is actually when Talos came into our view. We aimed to do this, and that's when we found Talos. And I've heard that in other talks as well. We looked at this, and we looked at that, and we looked at CoreOS, and we looked at I know, like what is Flatpak Linux or Flatcar Linux. That's the one. There's a bunch of stuff out there, but what we really wanted was found in Talos, and then when we started talking with the guys at Sidero, with Andrew and Steve, that was just a great fit. So reducing complexity. The problem is we reduce complexity first, and then we introduce Kubernetes, which I conveniently just draw as a very thin line. And the reason I can draw it as a very thin line is also because of Talos. So, what does that imply? If I take the old Juju and director type deployments, what does that imply when I kind of switch that out and put Kubernetes there? Well, first of all, we can let the databases and the RabbitMQs and all of that, we can sort of push that into Kubernetes type management, because there are so many applications that are using that. There are very good operators to do that for us. So there is a choice there that you can make. You can do it with OpenStack Helm Infra, which is a sort of side project of OpenStack Helm, where they do all the secondary parts that you would need to run OpenStack. They manage it there. We chose to not use that if we can, because we love operators. They just work for us. You just need to know how to tweak and tune them, and then let's keep it there. So that's already complexity sort of managed for us. Now the OpenStack Helm container images, we don't really have to worry about those, because those are there and they are stable and they work. So that's number 2. We opted to go with Argo CD. I think every other talk here also has Argo CD in it, so I have some in the demo, but maybe I can skip over it a little bit because I think everybody knows it. But what Argo CD brings us on top of what we used to have is just continuously managed services and understanding that everything is the way it is, and it provides us with a true GitOps way of working, which with the other methods is almost impossible. After OpenStack Helm, we use Customize here and there to tweak some stuff in the result, and that means that in our development environment we can now spawn OpenStack clusters really quickly if we want. We can just in minutes we have one running. The big one for us is in the other slide. We had a big part under here which said accidental complexity, and most of that is just gone because of the cluster management and monitoring that is built into Kubernetes. We no longer need things like core sync and all of that, and that is actually where a lot of the problems come from in OpenStack. That's a lot of the challenges and the technical problems that you are going to encounter are coming from. So what does this is sort of, I think this is the simplest schematic I can give you about how a compute node, for what a compute node normally looks like. So you take some hardware, you put an operating system on it, you put an ISO in it, you click next. Somehow you get Nova compute there. Usually in a traditional environment, it's either an apt or an RPM. That will pull in also libvirt. That is also an apt or an RPM. That will install itself as a systemd service. They will start, and magically everything will work at the first try. But this is how that works, and this is just a mutable system. There's no containerization going on, and the virtual machines are just running. They're just running on the host operating system. They have access directly to the dev KVM, so that means that they're hardware accelerated, true virtualized, not emulated instances, which means speed for everybody not familiar with virtualization. So this is the ground floor basically. Then we have the OpenStack Helm way of doing stuff. And I don't think we've deployed OpenStack Helm environments, but we never really had second guesses about this this architecture. But what it does is they push two containers to the compute nodes. One of them is Nova Compute. The other one is libvirt. What the libvirt container does is kind of weird. And I think it's kind of something that most people in Kubernetes land don't like, because what they basically do is let that run with the highest privileges, give it full access to the host operating system, then instruct systemd there to create a transient service called libvirt, and then libvirt actually runs as a systemd service on the host. So it's uncontained. It's no longer running in the container. There's a nice side effect of that, and that means that your virtual machines are started on the host. They are also uncontained. Yeah, anybody spot the problem here with doing this on Talos? So there is no systemd. So that's when you're trying to build this stack, by the way. This is probably not the first step that will fail, but it's definitely one of the steps that will fail initially. So there's a couple of things. You don't have systemd, but there's also no way really of changing the host operating system or really doing something with it. Not really the host operating system. You can build extensions and you can build other containers, but there's no such thing as running something outside of a container on Talos Linux. So we were talking with Sidero about how to approach this, and I'll show you how we did that. So the challenge basically is, first of all, conceptually, how do I start libvirt and how do I make the container run and then have it be able to start hardware accelerated virtual machines? And then how do I do interaction between those two? Because here actually Nova has a lot of privileges as well, because it needs to talk to libvirt continuously. For the networking, by the way, we just have a dedicated port, and that gets used by OpenStack solely. So we do all the Kubernetes management on the left and all the OpenStack management on the right, basically. So this is what we currently are using. So we, in the talks with Andrew and with Sidero Labs and in running Talos, one of the challenges that you'll face is you'll have your existing paradigms when you're coming from an OpenStack environment or from a virtualized environment, and you have some of the preconceived ideas about containerization, and you have to sort of merge them. And as long as you are in an environment like this, you can sort of cheat. You can take two worlds, and I don't know if it's the best of both worlds or the worst of both worlds, but it is two worlds combined. So we decided that it was actually a very good idea to just put everything in the container and have it like this, because this system is not going to do anything else than run virtual machines. It's an OpenStack infrastructure doing OpenStack virtual machines. Yeah, so it has a few privileges to get to the devices that it needs, and that's about it. Really quite easy if you figure out what it's actually trying to do and going wrong. So I'd like to show you a little bit about what the environment looks like and what we're using to actually build this. We are using Omni. I don't know how many people here are using Omni. I saw in the Omni talk about 5 hands or 8 hands. Yeah. So you'll see some familiar things. Those of you who don't use Omni, I strongly urge you to try it. So this is the Omni interface. We have a few, this is in our dev test environment. This is the machine overview. Everything you see here are labels where you can select your hosts. So if you create a cluster, you can say, I want this many hosts with this label. That's where the labels overview are. This cluster has one control plane node and 3 workers. And if you look at the left, the part that was now collapsed and is now opened, that is exposing services through the Omni interface. So those are services running inside the Kubernetes plane, exposed through Omni. And you can see that in the URL as well. This is all transparent to the admin or to the user. We now see Argo CD. This is mostly, I think, only running OpenStack at the moment. So you can see there are a few applications defined. So everything in Argo or everything from OpenStack is a different application. Here we see the Galera cluster, the MariaDB, and Cinder. You never guess what backend we're using for Cinder storage. It's Ceph. One of the things that is really cool is that from the OpenStack perspective is that a lot of the things were sort of disconnected before, and now it's really integrated and really connected. So you can really go through the entire environment, and if you use Argo CD, you can really click around, and everything is integrated, connected, and understood to be working from one overview. So in a minute you'll see we'll go to the OpenStack interface. I just want to show you how to create a virtual machine, where those are running, and that it's all working. Let me just skip through this a little bit. These are some of the OpenStack logs where you can see things being created. So here you can see you can go through to the OpenStack interface through Omni actually, so it's still proxied by Omni. Let's first delete the virtual machine that's there. And what's really nice about it, it's very responsive. Also, creating the virtual machines is just really quick. So I'm going to create 10 Debian virtual machines here. Probably small ones. This is all, what do you want to base it on? This is image selection. So I've heard golden image here today, like 3 times I think. It's been a while, but golden images. And there we go, launch instances, or launch instance, building, scheduling. So this is all a whole lot of communication in the back end of OpenStack going on. This used to be like one service doing all of this. It's now been split out into much more scalable, smaller services. So they're now running. Let's see what that looks like. One of the things that we think we need to sort of resolve in this era where we're combining cloud native and infrastructure as a service is how do you deal with everything? How do you deal with the whole of it? And conceptually, the difference between OpenStack and Kubernetes is vast, but you can also see that it's very different in the way you push it into an organization. And one of the things that we see as being a challenge there is if you go into most of our customers, you will probably be able to count the OpenStack clusters on one hand, maybe two hands. We have one customer here who has more than one handful. But most are, it's very much a thing that you do for your entire organization once really well. Whereas if you walk into the same customers and you ask how many Kubernetes clusters do you have, the answer is more than 5. And not just a bit more than 5, there are many at the same time. So doing something for the entire organization once well is really not the world that Kubernetes lives in, which also means that KubeVirt it lives in a different place. But if we're doing Talos with Kubernetes with OpenStack on that, and you want to do Kubernetes on that, you want those virtual machines to be able to do KubeVirt maybe, because that's where you do want the combination. If an application team has a need for virtualization, so these virtual machines that get started, they are virtualized and they get the nested virtualization flag, so they could launch a virtual machine inside the virtual machine, which will perform differently, but it is possible. So here we go into the container, the libvirt container. And that's where you really can see the virtual machines running and the configuration and the libvirt stuff that's happening. So the main difference on this level between what you will see with a KubeVirt and OpenStack is that with KubeVirt you will see one container with libvirt in it with the virtual machine, and then the next container with libvirt and the virtual machine in it. Here we see libvirt virtual machines. So very much a pet, this. A traditional XML configuration. There we go, log files, it works. So we've experienced that everything that normally works in an OpenStack environment just works on this level as well. So it is very much, once it's presented, you really can't tell the difference anymore. These are the QEMU processes running happily. All nice pets. Yeah, so this is another example of this is the nested virtualization flag that gets passed through to the virtual machine so that you could use another type of virtualization if you would want to. That's it. Let's see if I can click somewhere and not start the video again. There we go. So this is some of our adventure of running OpenStack on Talos. If you would like to know more, you can reach me on Slack. On Sidera Labs is Talos Slack. I've also been involved in a thread on the GitHub there about this. I'm here, so And if you want to know something more about our service levels and all of that, Michiel is over there, so please tackle him and talk to him. For me, that's all I wanted to bring today. So if there's any questions, I'd be happy to see if I can answer them. I believe there's the mic.
Impressive.
Hey.
Thank you for the slides and the presentation.
Thank you.
It's quite amazing and was really fast deploying all those Debian VMs.
Yeah,
But I'm not sure if I really understood it, so help me out a little bit. So you are using OpenStack to deploy the VMs as pods?
No.
Because how did you manage to set up the Talos cluster, and then on top of it be able to deploy VMs using libvirt? I didn't get it.
Well, it's I think conceptually what we're trying to do here is I'll see if I can explain it from another direction. Well, how it's possible is we're running everything in a big container basically. Not everything, but the part that you were talking about.
On top of Talos?
Yes. Yes.
As a pod?
Yes. Yes. So libvirt is running as a pod. Yeah. With all the VMs. And what we're aiming for is to do A/B upgrading there. So one of the challenges is as you saw in understand that the overview I gave you for what OpenStack looks like is super simplified. So it is like a lot of communicating parts, and it works really well and scales really well because it's a lot of parts, and you can scale all of those parts, and there's a lot of function in the fact that it is complex, but it is still very complex. So what we want to work towards is have an immutable operating or an immutable infrastructure for that type of application. So we want to be able to say this part of OpenStack is known to work, or this part of this application, I don't care if it's OpenStack, but this part of this application with this version, and this version is a known set to work. And then this is a new set that I also know that works, and then I'm moving to that. And that is something that is really difficult in current OpenStack infrastructures, because you do, at some level, something somewhere does apt-get upgrade. And then you're left in a sort of, or it's yum upgrade, or it's whatever, DNF, but that's really the difference between most traditional operating systems and traditional ways of working, is that they're solving a lot of problems, but they're all problems I'd rather just not have, sort of that, in this sort of stack. So what we're trying to figure out, and we're actually doing, is saying, we know this set works. We know it because it's working right now, and we know it because it got here in a testable way. And then what I don't want is for this part to be updated and this part not. So we already know that this set of libvirt with that version of QEMU is going to be running. And I used to care a lot about the operating system below it, but now I don't anymore. So I care an awful lot about Talos because I love it, and I love what it brings us as a company, but technically I really, at this level, I don't care about it at all. And that's also why it's so easy. I say try Omni with that reason. That is, you created a cluster, and I kind of went, yeah, we do, but that's really not where the work is anymore. And we do that, actually, kind of could have mentioned that, but all of this is just bootstrapped from a bootstrapper that we wrote in Go, where we take everything that we want, and it used to be bigger. We're actually shrinking our bootstrapper as much as we can, because we want to push everything to GitOps. We want to push everything to, so we have a bootstrapper that talks to Omni and says, create a cluster based on these parameters, and then it pushes everything in, and then GitOps takes over with Argo CD. We link it to an externally hosted in another data center of us. We host OpenBOW. So I was in a talk and Volt was mentioned, and somebody, I think it was Tim, who asked, "Is there a fork?" There is a fork of HashiCorp Vault. It's called OpenBOW. That's what we are using for secret management. If you go to the documentation of OpenBOW, it still says go to HashiCorp for support. And it's kind of ironic that the fork was created by IBM, which then wound up buying HashiCorp, of course. But we're using that. We're using that because it feels a little bit more open source than the other open source version. But that's how we do that. So that connection is made, and then all the secret management goes into there, and that's it.
Thank you. I just want to ask if you did any research about using KubeVirt, and can you tell a little bit more about advantages of or disadvantages using OpenStack and running it in Kubernetes over using native Kubernetes virtualization? Thank you.
Yeah, I find that yes, I can. Yes, we did. And yes, we are. So yes, we are still researching that, and we're actually not. We're working on integrating KubeVirt into this platform as well, because to us it serves a sort of different purpose. So one of the things that we see is that our customers are asking for a next step in OpenStack, and then KubeVirt is just simply something else. So that's one of the reasons. So that's an easy one. The other one is it does a great job, but it's still a pretty small job, and it doesn't fit organization types yet. And I think organizations need to adapt to, still are adapting to the Kubernetes way of working, not only technical like GitOps and all of that, but also how do you organize teams, how do you organize all of that self-reliance. That's still in development, and there are a lot of organizations that just have infrastructure teams, and they need that team to have a part of the infrastructure to own, and that is what OpenStack does great, and that, yeah. So basically, indeed, multi-tenancy is the way to do that, and that works really well in OpenStack, and it is, you don't do a paradigm shift when you. If you look at it from sort of a VMware point of view, you can have like 2 days of training and be an OpenStack guy. It's just you're gonna have to get used to the command lines and the colors of the logos, but all of the naming of things is just, oh, this is called this here, but it's still the same concept basically, and that's going to be a lot different when you introduce a way of working that involves actually doing Kubernetes. But it has a place in this stack as well, because I think what we're seeing is a challenge to integrate all of those worlds, to integrate not only the technical part of it, but you also need to integrate the organizational impact that does. And that is something that is easily done if you just have 250 virtual machines. But if you have 2,000 hypervisors, that's a whole different story. Then that implies that you have dozens or hundreds of teams working in this way, and then still, if you are impacted and with these changes at Broadcom, then how are you going to handle that? And we feel like investing into a way of working that at least provides you with the infrastructure as a service way, in a cloud native way, that prepares you much better for a future that is solely cloud native than just doing it in a traditional way. Does that answer your question? Okay. There.
Just a basic question. Do you run these libvirt pods as a daemon set, or?
Yeah, I think so. Yeah, I think so. Pepijn, here.
feel I'm repeating myself from a previous talk. What about networking?
What about
What
network?
about the networking stack you use for the Talos Kubernetes cluster?
Right now, we kind of split it out often because we're often integrating. So we're splitting it out, and by that I mean we basically leave one interface fully alone, and that's fully managed by the OpenStack part. And that for us is a very easy solution, but that's also I started with answering his question. I started in a different direction, and that's actually for me much easier way to explain it. There's two things why we're using this. If you look at it from another point of view, we know we have to provide infrastructure to organizations. You can do that in several different ways, but what we're really trying to do is wrangle this infrastructure in doing what we want it to do. We choose to use OpenStack for that for years now, or we chose to use OpenStack for that, so that's what we're known for, and that's what customers are also approaching us for. And in general, things are more and more be containerized, and then you start to see that you have things like doing OpenStack containerized on Podman, for instance. So to us, that's like a half measure. You go and take one step. So then it becomes the other way around. You start to think about it the other way around. If I have to orchestrate containers, how do you do that? Any IT room where you ask that question, 90% of the people will say, yeah, Kubernetes is the way to go, probably, but your mileage may vary, but that's the default answer. So if you look at it from that way, you start to think about how do I do this with Kubernetes? And then it becomes a really weird kind of way, because Kubernetes world is very dynamic, as in the people working with Kubernetes are very dynamically thinking people. They're thinking about short cycles, updates, stateless, and we're talking about virtual machines. There are no better pets than virtual machines. You love them, you want to nurture them. So what we're really doing is taking these systems and saying, okay, we've got this super dynamic system that can orchestrate a lot of things, and then we're doing basically one thing with it. So for us, we've always gone into these data centers fully understanding what these machines need to do, because they need to run OpenStack workers, OpenStack compute nodes. Or on the other side, a storage node in Ceph doesn't become a storage node in Ceph by accident. It was designed to be put into the system like that. So we just say, yeah, you have to have two interfaces, this, and this, and that's specific. So that's really how this is going. We've always had an interface on these OpenStack machines to manage it, and an interface for the client traffic, basically. And that's how we're doing it now. The default one that comes with it, and then the other interface we fully ignore. And on the Kubernetes level, we just go, don't do anything, and we sort of do an init container, kick off some things, and then OpenStack takes over with Open vSwitch. So, but to be honest, I'm giving a talk here, but we were doing this with a team, so I don't know all the details of everything of all of this stack. Fortunately, I don't want to either. Anybody else? Well, then we are on time for drinks, I think. Thank you very much.